Welcome everyone. We are in our one-dimensional kinematics notes. We're going to scroll on down here to page 8 and we are going to look at example number 2. Example number 2 is about an airplane taking off, and we know it has to reach a certain speed before it can do so. We know we have a certain length runway as well. So what I'd like you to do here is take this and put this situation, which is given to us in words, and put it into a picture. And so what I'm going to have you do is actually stop the video at this point, draw the picture of what is happening in this situation. Pick up with me once you've finished that. All right, here we are back at the problem. We know our plane is probably going to have to start at rest to take off, and we know it has to reach a speed of 100 kilometers per hour. We also are told that its acceleration is 2 meters per second squared. Once again, since my arrows seem to all be pointing to the right here, I'm going to call the positive direction to the right. Now, notice here, I have delta x, but I have a question mark beside it. Now, I want you to think about this once. Why don't I have 150 meters marked right here? I am going to have you go ahead and stop the video here and think about that for just a moment. Well, we're back, and what I want you to think about here is we are told this is 150 meters, and I want you to really think about this when you're given a problem. Don't just blindly take numbers and say, "Oh, length. It's got to be a displacement." While that's a pretty obvious thing to put it in as, you really need to think about this. It doesn't tell us that it takes 150 meters for this plane to get to 100 kilometers per hour. So what this is kind of a limiting factor for this plane to take off. We know it has this 150 meters, but we don't know that it's going to need that much. We just simply know that that's how much it has. So I'm going to call this length here, I'm going to call it just the length of the runway. I'm going to call it the distance d. And really what we're trying to find here is, do we know if there's enough room? We're not really not sure here. So when I go to my knowns and my find, let me shrink this down just a bit. The knowns, of course, we know it starts at rest. We know that its acceleration is 2 meters per second squared. We also know that it has to take off at 100 kilometers per hour. Once again, notice here that our units don't match up. So I did a conversion, and in this case I showed it to you, getting 27.8 meters per second. And we also know the distance that it has that has to take off is 150 meters. So what I'm going to try to find here is I'm going to try to find the delta x. I want to see how far does it actually travel to actually do that. So I am going to have you stop here. I'd like you to kind of look through your equations and figure out what equation would you use to solve this. All right, so here we are. We're back at the equations, and the equation I chose because I knew VO, or V sub O, V sub F, and A, and I'm looking for, here we are, there it is, delta x. I chose the time-independent equation. And so since my final velocity is in the positive direction, notice I can confirm that here. It's there's the positive direction right here, and it's in that direction. I'm putting a positive in for that because, again, velocity is a vector, so it has a direction, positive being the direction. My original velocity is 0, so I've kind of canceled it out here of the equation. I know that the acceleration is positive, so I have a positive here, and I know my displacement is positive, so I put the positive on that as well. Now, with these problems, you can always put positives and negatives on the numbers. I like to put them on the variables. One way or the other, you have to take account for the positive or negative. So after I simplify just slightly, I end up with what I see right here. Doing a little bit of algebra to isolate the delta x, the displacement, I would need to divide both sides by 2a. And of course that leaves me with the delta x equals vf squared, or v sub f squared, divided by 2a. Now, as always, it's always a great idea to check to make sure that you've done your algebra right. And I like to do that through my unit analysis. And again, here's my unit analysis checking out. And in the end, I do end up with the meters as units. And I go back and say, well, I'm looking for a displacement. and meters are units of displacement. So the units do check out, that's okay. So it tells me that I probably have done this algebra correctly. Of course, it's not always a fail-safe, but it's a good opportunity to check yourself. So I put my numbers in here. These are substituted in from our known section. I end up calculating delta x and find out that it is equivalent to 193 meters. And I go back to my original question, which was, is this 150 meters long enough for this plane to take off? Now, if it takes 193 meters to take off, and it needs 150, this is obviously not going to be long enough. So the plane, in this case, will not have enough runway to take off.